Consider the function of x, log 3x plus 1. State the domain and range. So if we think about the standard log to the base 3 of x curve, it is going to have its asymptote as the negative y-axis, and then it's going to go over like this. Despite the fact it curves over, if you increase the x value, you still increase the y value. So the domain here is going to be real values greater than 0. There's nothing to the left of the y-axis, and the y-axis is an asymptote. So that is our domain. The range is just going to be y is a real, because it goes all the way down to negative infinity, and this will keep going up. Find the equation of any asymptotes and the coordinates of any axis intercepts. So, I should have just mentioned that adding 1 won't make any difference because it's a vertical translation to these. So it's exactly the same as it is for log 3 of x. Okay, so the asymptote is still going to be x equals 0, the y-axis. The axis intercepts, so if we think about y is equal to log to the base 3 of x plus 1, the x-axis intercept, which is the only intercept, is when y is equal to 0. So what we get is log to the base 3 of x is equal to, plus 1 is equal to 0. So log to the base 3 of x is equal to negative 1. X is going to be 3 to the negative 1, which is 1/3. So we're going to have 1/3 0 as the x-axis intercept. Now we're asked to find the inverse function. Now there is a technique for finding inverse functions. Start with y is equal to log to the base 3 of x plus 1. We know that this is going to be an exponential of some sort. So what we do is we interchange the x and the y, and then we try to make y the subject. So log to the base 3 of y is equal to x take away 1, and then go for the equivalent exponential form, y is equal to 3 to the x minus 1. So the inverse function of x is 3 to the x minus 1. We're now asked to sketch y equals f of x, y equals the inverse function, and y equals x on the axes below. And let's start with y equals x, because that is a nice, easy, straight line that we can draw. And so that is y equals x. Now, our log function was log to the base 3 of x plus 1. We know that the x-axis intercept was at 1/3. We worked that out. And we know it asymptotes down the y-axis like so. So let's think about when x is 3. We'd have log to the base 3 of 3 plus 1. 1 plus 1 is 2. So 3, 2. Let's think about when x is 9. Log to the base 3 of 9 plus 1. Log to the base 3 of 9. Log to the base 3 of 3 squared. 2 log to the base 3 of 3. So that's 2 plus 1 is 3. So that would be here. And so that one will go like this. Now, the e to the x minus 1, that is going to be a reflection of that in the line y equals x. Probably should label this one. So that is log to the base 3 of x plus 1. So let's think about that. So when x is 0, 3 to the negative 1 is a third. So that gives us this point, which is good because it is the reflection of that point there. Then the reflection of 3, 2, that is going to be at 2, 3. The reflection of 9, 3 will be at 3, 9. So that is going to go over like this. And the reflection of having an asymptote down the y-axis is going to be to have an asymptote along the x-axis, like so.